Hi, Christina. How are you? Uh,
Hi, how are
so
you?
good. And before we start, yeah, I got your emails about the discussion. So I have to
Yeah,
I have
it,
to figure out how to change your grade, but I will. I don't know. I haven't figured out how,
yeah, it was my mistake for the peer review. When I was clicking like the discussion peer review instructions, the instructions just weren't loading on my computer. So I was like, oh, let me just like reply. Like maybe that's what it was intended until I jumped on like someone else's computer to see, and it was like there's a whole different way of doing. Like you have to comment and then you send a rubric through, and I was like, oh
yeah.
shit.
Yeah. I think
Yeah, it's
like
my mistake. I didn't,
I
you know.
yeah, no, I couldn't see the your responses for some reason on my end I couldn't see your responses pop up. So I think that there is something that was probably going on. Like if
Mm-hmm.
you couldn't see it and I couldn't see it, that there probably was some issue over the
Yeah,
weekend. So I
yeah.
which means that there's still an issue with me changing a grade. So I'm going to check again, but I'll change it. I
It's
just
okay. Take your
I
time.
don't know,
No worries.
I don't know what happened, but I think you're right.
Yeah,
Something wasn't
yeah,
quite right with it, but oh
yeah.
well.
I sent over the discussion as a PDF to in the email just so you could
Yeah,
see it, you know?
I don't know what happened, why I still can't open those files, but I saw that too. And so I don't know, but
Yeah,
as
it's
long as
okay.
you did it, then I'll fix it probably this afternoon. I have to go to the dentist
It's okay.
because
Take you're good.
my tooth broke over the weekend too.
How did it break?
Like it's like a crown, and so it wasn't like the strongest material.
Yeah.
It's because I grind my teeth at night, and so the dentist didn't know she needed to put the stronger material on, and so they've all been cracking one by one.
Oh,
So it's not like they all cracked at once. Like it's been two last year, one this year.
wow.
It's sort of she can't replace them unless they're actually broken, but she wants to replace them all, but she can't. So if she would have known, but
Yeah,
it
that
is,
sucks.
yeah, unfortunately, but it is what it is. So let's see. Hi, Zyma. Let's see. So let's see where my note is for these because I feel the quiz, if you now I will say on the quiz, if you if for some reason you honestly my opinion on the so I don't say this anywhere in writing, but um if you ever aren't happy with your quiz score for some reason, if you go back to the practice quiz, so chapter 7A practice quiz, and you go back and you get 100%, and then you email me or send me a message and let me know, then I'll let you retake the quiz. But I feel honestly, here's my thing, if for some reason you're not happy with your quiz score, and then you don't go back and practice again, and there's really no reason to retake it if you're going to get the same score, so if you go back and get 100% on the practice quiz and let me know, then I'll let you retake the quiz. So just keep that in mind, if for some reason you didn't like the score that you got. So but that's my main policy, is in order to do that I want you to get the 100% of the practice quiz, because I don't want you making the same mistakes on the quiz a second time. It just doesn't it doesn't make sense to me. So But otherwise, we'll start on like chapter 7B and then move on from there. But there's something like on the practice quiz for some reason, like you need help with still from 7A. Just let me know which one like you're stuck on, and then we can go from there. Like I really don't see any reason why, like, like everyone, like for me, it's not even about the fact that you, it's not even about that of the grade for me, because I don't mind, like if everyone were to say get 100% on all the practice quiz and then 100% on all the quizzes, like that, then that means like, yeah, you actually like know it. And if you don't know it, you don't know it, and then it gets harder and harder is all I can say. So all right, let's see. So this is a new section, and just like before, I'll sort of like go through and tell you where these are all from, and then we can go from there. But this first one is from 7.4. So, and by the way, like if you feel like you're a little bit rushed, like don't feel too rushed, because the 7.4 through 7.6 is a little bit more time on the schedule. So it's not like one chapter or half a chapter per week, so this is more like a week and a half rather than just like the first week. So that it will be a little bit more time. It's because there's like 6 like half chapters in 8 weeks, so they're spread out a little bit all over the place. But this one right here is, if t is 15 pi over 4, then use the rectangular coordinates to find sine of t and cosine of t. So I will say that you could honestly do this by by uh, looking at a chart or the unit circle or whatever you would like. And by the way, just so that you know where I put them, because I don't actually know if I showed it last week, but inside of the Canvas, I put a Google Drive link in Canvas. And so I put it there, but I can't remember if I said anything, but it's there. And then from there are, what? Okay. I don't know why only the unit circle is showing up when I go to that link. That wasn't supposed to happen. So maybe that's why I thought that I showed it, because somebody asked for that unit circle link, and this is probably why Canvas was down last week. But I want to fix it right now because I want to show you that document regardless. So if I can type it, like it will. Yeah, this is really like why it would do this to me, like why it would just like, yeah. So it's actually going to be this link as soon as it pops up, but I don't know why it won't. It's supposed to be this link and not just the unit circle. It's supposed to be the notes, like the scan things that I had. So then whatever one from last week had the chart on it that I showed you is, see, that's not even the right one. So I don't know why this is doing this. So I'll fix it. I promise. I don't know what happened though. So regardless, I'll fix it. I don't know why, but if you, even if you Google unit circle, you'll find a chart, but it might not be the same exact one that I have, but if you look at it, it is right here. And so these would be the T values, the radians, and then all of these would be the uh you know what, I should actually say this. This would be the coordinates of P of T. So if the T was the 15 pi over 4, then you do need to be a little bit careful about this, because you're going around the unit circle more than once. So this is why that discussion problem was there about subtracting the 2 pi or adding the 2 pi as many times as you need to. But if you go around the unit circle, and this is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, then 9 pi over 4, 11 pi over 4, 13 pi over 4, 15 pi over 4, then you know that this is the angle that you're looking at right here. So the whole spiel really goes like this. It's that you can draw a triangle right here, and then because this is really the unit circle like this, that and by the way, this is actually like a really poorly drawn unit circle, but I think you get the point that this is radius 1, and then this is actually a radius of 1. And then actually, why did I not actually draw this the way that I want it to? This is actually not 1 because of my I told you my drawing wasn't gonna look right. So I already know that my drawing is not going to look right. So I don't even want to like fool you on that, because it's really, yeah, it's not gonna look right. It's really not gonna look right, is it? My drawing is not. And this is why I didn't want, yeah, I should have just printed out the circle, because now I think that I made the drawing worse than it really is, because if you just look at the chart, you see that this was 15 pi over 4, and this was 7 pi over 4. So then you just look for 7 pi over 4 on the chart, which is why I wanted to give this to you, and then look for sine and cosine. And so these would be the values that you need, and that would be the end of the problem. So these are just values that you either know or you look up. So that is the issue that I have with this, is that it is yeah, this is 1, what is this one? This is square root of 2 over 2. So negative square root of 2 over 2 and square root of 2 over 2. So that's what I'm talking about, is that was the sine and that was the cosine. So my advice is really that, and it's to uh, try to look at these with some, yeah, I knew that if I told you this, like that I drew my circle a little bit crooked, it would make sense because this isn't actually like, it looks like it's one, but it's not. So this actually shouldn't have been, this is because my drawing skills are so bad, but it should look more like that. So this is R is one, but then this actually isn't, that actually isn't one. That's the issue. That's why I never draw anything. So yeah, that's what it is. And so this side actually ends up being the square root of 2/2, and this one negative square root of 2/2. But the only reason why you would actually know that is because this is actually, if you look at that triangle right here, this is pi over 4 in 90 degrees. And if this is R is 1, then this is also pi over 4 because it's a 45, 45, 90-degree triangle. And so in those types of triangles right there, then what happens is usually you would see that they would be 45 degrees, 45 degrees, and then 1 square root of 2. But the issue is that because this was 1, then they're going to divide these all by square root of 2. So that square root of 2 over square root of 2 of 1. So then that's how you get 1 over the square root of 2 or square root of 2 over 2. So that is actually why it's square root of 2/2 and not just like square root of 2. So yeah, that's also why they say to memorize these. But this will, what I'm going to say next, I think comes up in the, I think it comes up in the next. Yeah, okay, so yeah, it comes up in this section, so I want to say it right now so that you hear it. So if you were wondering why this one was negative, then it's because, see, like this is in quadrant 4, so this is a negative y value down here. So this point right here is actually the square root of 2/2, negative square root of 2/2. And then if you remember, like last week, this was cosine of t, sine of t. So that's why this one ended up being negative sine of t, and that one ended up being positive cosine of t. But there's actually a little bit more to the story than that, and it's this. So if you have quadrant 1 and then 2 and then 3 and then 4, then what happens is that you have positive and you have negative, and so positive, negative, positive, negative, positive, negative. All right, so in quadrant 1, all of the values will be positive, like sine of t, cosine of t, tangent of t, cosecant t, secant t, cotangent t. But then in quadrant 2, the only ones that are positive are sine of t and the cosecant of t, but the rest of them are negative. So cosine of t, tangent of t, secant of t, cotangent of t. So if you look at the chart that I gave you, do you see what, like, do you see why like some of these are shaded gray now? Because in quadrant one, all of them were positive, and so that they're shaded in. But if you're in quadrant two, then only the ones in the sine and the cosecant column are actually uh, positive. So that's what I'm talking about when I'm talking about this right here. But then if you have the quadrant three, and quadrant three, then you have tangent of t is positive, cotangent of t positive, but then all of the rest of them are negative. Sine of t, cosecant t, cosine t, secant t, and then in quadrant four, cosine of t, secant t are positive, and then all the rest of them are negative. So sine of t, cosecant of t, and then tangent of t and cotangent of t. So just as, as a double check to even like looking at the chart or like calculating the values, then you could like look here and make sure that, well, all right, this wasn't 15 pi over 4 is in quadrant 4. So sine of t should be negative and cosine of t should be positive. So that's why that's where I would combine all of that information, right? So I would say, well, it's in quadrant 4, so to double check, then sine of t should be negative and cosine of t should be positive. So do you have questions, or does that help a little bit? Or if it, like the other thing that I would say is that this is something where I feel like no one really like shows this, but I'm not sure why, but like people you can use your hands to show, can you like seeing like the hand trick for the remembering the unit circle? Because if you have, then I won't say it, but I have a diagram of it, but I can't find it, so I might just have to like show it. But I really would prefer to like actually like give you this. If you Google it, like unit circle hand, but I can't find my diagram, so it's probably gonna be, this one isn't a bad one. It's just that like I usually, like I feel like you have to be careful because of like if you use the right or the left hand, you see what I mean? Like they are a little bit different, but if you look here, this is what it is. You use a number of fingers to tell you where the where you are in the unit circle. So the best one, if you want like a formula for it, would be I just saw it because this is the one that I use. And then I didn't see it. The one with the square root, it has a square root on it, but I did not see it. So, this one. Yeah. So that one right there, but actually this might be, that one tells you about the, oh, there it is. That's it. Like that might actually help you a little bit more. Or this one, this actually is a little bit better if you like want to use your left hand. I usually like pick up my right hand, but if you see my issue with this, if you use the left hand, then the 0 starts on the wrong side. So that's why I would say use the right hand. But in general, though, here's what I would do. And now I'll probably like show it. I'll show a few times if you think that's helpful. But do you see how this was like 45 degrees, or pi over 4 is the angle? So if you want sine of, say, the pi over 4, then what you would do then is you would draw your hand and say, well, all right, you have 1, 2, 3, 4, and then your thumb right there. And so then what would happen is, now again, like if you don't actually like this, I won't be entirely I won't be offended, actually. I really won't, but this is actually how the numbers go. So this actually would represent the right pi over 2. And then think about how this would go, but pi over 3, then pi over 4, and pi over 6. And then over here, right, is if you draw the axis up a little bit, like where the thumb line is, then this will be 0. So your hand is, my hand is just looks like a hand, but like I said earlier, my drawing is really, really bad. But then if you say want sine of pi over 4, then that would be the, right, it's one of these things where you have to like visualize it, but you have to take the number of fingers that are what is it? Yeah, below the pi over 4. So here is pi over 4. So it's this finger right here. So there were 2 fingers over here. 1, 2. So you take the 2 and then divide by the square root of, where was it? Because I'm telling you, like, this is why I wanted to just print that out, but my computer just doesn't do it right. Then, and this is why I probably should just like show the video, but like it's fine. I think that you get the idea. So the square root of the number of fingers, right? Fingers below over 2. So there were 1, 2 below that. So square root of 2 over 2. That's how it works. So if you say want it the sine of, say, pi over 3, then same idea here. You have big finger, then 1, and then 2, and then 3, and then the thumb down here. So pi over 3 was this one right here. So this would end up being, there were 1, 2, 3 fingers below the pi over 3 fingers. So it would be square root of 3 over 2. So maybe that helped, maybe it didn't, but it is one of those things where I think it does like help a little bit. Like if you're like because for me, like I know that sometimes I'm just like, even if I don't intentionally count on my hand, I like tap like 1, 2, 3, 4, just to keep track of things. So it can help, but then if you know these, then you can use these to help you tell if it should be positive or negative. So then if I look at, say, question 2, then the point of 5 pi over 3, actually, you know what, I'll write number 2 on a separate sheet of paper. So number 2, rectangular coordinates of p of 5 pi over 3. So then let's see. So the x coordinate will be the p of 5 pi over 3, and the y coordinate will be the p of 5 pi over 3. So the x coordinate of this will end up being, again, it's always the cosine of it. So it is cosine of 5 pi over 3, and then whatever that is the value. And then the y coordinate is sine of 5 pi over 3, and then whatever the y coordinate or the x coordinate is there, and the y coordinate is the sine of 5 pi over 3. So 5 pi over 3, it looks like if you draw in thirds here, it is now, yeah, my thirds are not going to be very good. So I would say something like that maybe, and then something like that. So pi over 3, 2 pi over 3, 4 pi over 3, 6 pi over, sorry, that can't be right. 5 pi over 3. All right, 5 pi over 3 is right here. So pi over 3, 2 pi over 3 pi, 4 pi over 3, 5 pi over 3, 2 pi. So here we are right here. And the same deal again, that this is the unit circle, and I'll try not to draw it too poorly this time, but this is, say, the r is equal to 1, but this is pi over 3 or 60 degrees. So this will be 30 degrees or pi over 6 down here. So then if you go by that, then I do know that, the 1, 2 square root of 3 triangles are another common one that people actually encounter, right? So it would normally be, if this were 60 and 30, it would be 1 and 2 and square root of 3. But because this needs to be 1, you divide by 2, divide by 2, divide by 2. And because this is going downward, it's negative. So then this would end up being, then for this problem, a x coordinate of the right, the x coordinate would be 1/2, and the y coordinate, the negative square root of 3/2. So 1/2 and negative square root of 3/2. But like I was saying earlier, if you know this is pi over 3, then what you do is you just say, well, sine of pi over 3, if you have that same way of remembering this as I was saying earlier, then this is pi over 2, and then pi over 3, then pi over 4, pi over 6, and 0 down here. So pi over 3 is right here, and there were 1, 2, 3 fingers over there. So square root of 3/2, but because the because 5 pi over 3 is in quadrant of 4, sine of t is negative, and that went from right these over here. So that's why I said like there's a lot to keep track of. So therefore, the sine of 5 pi over 3 is negative square root of 3/2. But if for some reason like you didn't remember the cosine of 5 pi over 3, then I didn't say this one earlier, but I think that you can sort of get the idea, but that's pi over 2, pi over 3, pi over 4, pi over 6, and 0. Then if you want cosine of 5 pi over 3, or just like pi over 3 in general, then you see like here is pi over 3, but there was actually only one finger to the like technically like above that pi over 3. Oh, sorry, I highlighted the wrong thing. Like pi over 3 is actually that one, right? But then if you say that, then it's the square root of the number of fingers above over 2. So square root of 1/2 or 1/2. And then because 5 pi over 3 is in quadrant 4, the cosine of t is positive. So then you would just say, therefore, cosine of 5 pi over 3 is just a positive 1/2. So that honestly, if my choices, I'll be honest, like if my choices are like memorizing this large chart, or like just like thinking about these and then thinking about the quadrants, then I think I'd probably go with that. But I didn't say this part, and this will come up in the chapter if you haven't read it yet. But if you look at this, they'll say something like this, like they'll focus on these ones. And so in quadrant 1, all are positive. All values are positive. And in quadrant 2, the sine of t is positive, which of course that also means the cosecant of t is positive, but that's I think something to focus on. But tangent of t is positive, and then that means of course the cotangent of t is positive, but then cosine of t is positive, and then that of course again means like the secant of t is positive. But they'll say it as all students take calculus as a way to help you remember which ones are positive and which quadrant. So all students take calculus. So that's in the book, but I feel like, like that like I like it, but at the same time, I think it really like minimizes the fact of like how important this is. You know, like because it's like, please excuse my dear Aunt Sally, you remember it, and then it kind of goes away, and then at some point you make a mistake in order of operations at least once in your life at some point, and then you remember it again, you know, so what do you do? So do you have any questions or comments or anything, or? Okay, yeah, like I said, these aren't that bad, but like it just, oh, actually, this one is probably the one that says it like what I was saying, you know, like 0 and that it goes 2, 3, 4, 6, 0. So that's what that was all about, but there is that. So number 3. Oh my, where did number 3 go? So number 3 is also from 7.4. So number 2 was from 7.4, but number 3 is also from 7.4. So find the quadrant in which the point P of T lies if the following conditions are true. So I think that this is something where, right, like I just have to go off of that little grid that I just drew here. So if sine of t is negative and then cosine of t is negative, then the only quadrant where these are both negative, meaning sine and cosine are both negative, is in quadrant 3. So then that would be quadrant 3 right there. So there's not, yeah, there's not much to say there, but it, yeah, it's a little, it is important. And then this one, now it, again, it might be easier to remember the regular function. So if cotangent of t is positive, that means tangent of t is also positive. And if cosecant of t is negative, that means that sine of t is negative. So if you want tangent positive and sine negative, then that would be quadrant 3. So that would be that one right there. So nothing like exciting. You just have to reference that chart there. But you have any questions or anything else like about that chart or anything? Because I feel like I said, like, if you want that something more or less like that, then yeah, if you want something like that, it's would be more or less, you could, you know, you could actually print something out if you didn't want to, like, oh yeah, so this one uses, instead of all students take calculus, all science teachers are crazy. I mean, that's an interesting like take on it, but people have been doing this forever and ever, and so they just like come up with more and more ways to remember it all the time. So that's, you know, that's what I would say, but I wouldn't say that all science teachers are crazy though. Oh my. All right, number 4 is also from 7.4. And so then here, this one again is going to really matter about like a couple of things that are going on. So I want you to notice that cosine of t is negative and sine of t is positive. So if the cosine of t is negative and the sine of t is positive, then that means that you are definitely in quadrant, right, 2. So that means quadrant 2. So then if I draw this and I'm in quadrant 2 right here, there, of course, a couple of ways to do this. So just again, like keep that in mind. But I can draw a triangle like this. And by the way, if you like go through the actual practice quiz, it will even say that they use identities and formulas to do the problem, but that easier solutions may exist. So I wanted to at least like use this time to like show you what another solution might look like, but I'm not going to argue one way or another that what I'm doing is necessarily like easier or harder than another way. So this is just one way of doing this. And so if you think about what is happening, then usually the cosine of t will be adjacent over the hypotenuse. So the only, well, yeah, adjacent over hypotenuse. So then if this is the angle right here, then this would be your reference angle. So I want to make that clear that this is the reference angle, which is the angle that you can use to do all of this. So the adjacent side would be the 20 and the hypotenuse 29. But because it's in quadrant 2, this is a negative 20. So that's where the negative comes in. But whatever you do when you do this, I want you to remember that the hypotenuse is always positive. So if it's negative, then the negative goes with the other side, whether it's like a negative x value or like down a negative y value. So the hypotenuse is always a positive value here. So that is, that's what I mean by that. So then from here, you can use the Pythagorean theorem to find the other side. So use the Pythagorean theorem. So this would be a squared plus b squared is c squared, but the hypotenuse is always c. So negative 20 squared plus b squared is 29 squared. So 400 plus b squared is what is it? 841. So then if you subtract that, that's 441. And b is the square root of 441, which is 21. So that would be 21, which would make the tangent of t, right, opposite over adjacent. So negative 21 over 20. So do you have any questions about that? Because like I said, there's other ways to do this, but if you want to like connect back to what you were doing in the last 3 sections, this is what you would do. You would make it into a right triangle and then just lay it out like step by step like this after that. Just I lost my blue highlighter, so okay. Then I'll do B then, and B will be very similar. So tangent of T is positive, so tangent of T is positive, but then they want cosine of T negative. So that means that you are in quadrant 3. So that's the only quadrant where tangent of T is positive and the rest of them are negative. So you're definitely in quadrant 3. And then you can do the same thing and draw the triangle down here. So this is the angle, but I want you to see that this theta is a reference angle. So you're always going to base off all of this off of the reference angle, which is really the part why, like, remembering the idea of the reference angles was so important. And so tangent is opposite over adjacent. So tangent of T is 99 over 20. So opposite over adjacent. So that would mean that in this case, the opposite side from theta would be the 99, but it's negative 99 because it's going down. And the adjacent is 20, but it's negative 20 because it's going to the left. So that's how it actually became, right, 99 over 20 positive because it was a negative divided by a negative. And I think that's the tricky part sometimes, is that people forget the fact that these numbers are negative because a negative divided by a negative makes the tangent positive. But it's, it is what it is. You can definitely get this. I don't think that's an issue. The issue is just it takes time. And because it takes time, like that's why I said, like, I don't mind, like, if you try to do, like, take the practice quizzes again and then retake the quiz, because it takes time. Like, no one gets on the first try, I promise. So then the hypotenuse, you can actually find it using the Pythagorean theorem. So you can use the Pythagorean theorem. And so this will be a squared plus b squared is c squared. So negative 99 squared plus negative 20 squared is c squared. And then negative 99 squared is going to be yeah yeah 8,000 sorry 8,000 no, sorry 9,801, and then plus 400 is c squared. So that ends up being 10,201. And then the square root of 10,201 is actually 101. So this side is 101. And then sine of t is the opposite over the hypotenuse, so negative 99 over 101. So this isn't actually, like if you think about it, this isn't actually too much different than the last sections, but the hardest part is remembering like when the number should be negative now, right? And so if you don't remember when the number should be negative, then you will get an answer that you shouldn't. But you have any questions or anything you want me to go over again or anything like that?
So when the question is like it says cos t like negative, you have to go like make the numbers negative. But if it's like a is like sine t positive, that means we should use positive numbers, right?
Uh, so this is all about whether it all goes back to like this page here. So it said, so the cosine of t was negative. So that's a negative value. So I had to actually look for where cosine was negative. So it means like it's negative here or here. But then sine of t had to be positive. So that was here. So it had to be over here. So what So I think you have to be careful about is that in this quadrant, the x is like the x is negative and the y is positive, but down here x negative, y negative, and here x positive and y negative. So because this was over here, only the x value was made negative. But because this one was down here, then the x and the y value were made negative. So
Oh,
you see what I
yeah, that
mean
makes
now?
sense.
Yeah. So that's why, yeah, the quadrant matters more than anything else. So yeah, like it, so the reason why I said this is because it would be different if you accidentally made the 21 up here negative and not the 20. You see what I mean? Like, so like, that's why like I would say like figure out the quadrant first and then go from there. Um, let's see. I think that the next one is 7.4 still. So that's like number 5 on my list is 7.4. And so this is find the 6 value or the values of the 6 trigonometric functions of the angle if the point lies on the terminal side of theta. So it says do not give a decimal that has been rounded off. Oh, by the way, I am going to, just so that you see another way of doing the number 4 is that if you want to see it done using the way that was in the practice quiz using just formulas, then I'll scan that part, but I feel like using formulas doesn't help you sort of visualize how this relates back to the other section, but this one is if the point lies on the terminal side of theta, then this is xy. So you can actually draw this out and then say, well, all right, here is 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3. And there is the the 0.83, and you can draw the triangle and do this the same way as before, but you also could go back to what I was talking about last week. And if you remember the part where now this is where I feel like people get a little bit confused. So do you remember these formulas? And I said like, oh, well, this only works if it's on the unit circle with a radius of 1. So if this were your T and you don't know what that is, and this is 8 and that's 3, then you can use the Pythagorean theorem to find this. So if I use the Pythagorean theorem, then you have a squared plus b squared is c squared, 8 squared plus 3 squared is c squared, 64 plus 9 is c squared. So that is 71, is that, or 73, sorry, my adding is that bad. So c is square root of 73. So remember, the hypotenuse is always positive, so I don't need to worry about plus or minus there because the hypotenuse is always positive. So hypotenuse always is positive. And so then what I would say is, well, all right, the radius is not 1. So notice, like, if I were to draw a circle around this, the radius is not 1. So note that the radius is not 1. So if the radius is not 1, then what do you do? Or how can you find these? And actually, this should even be a theta because they only use T for the unit circle, which that kind of bothers me a little bit too, because like T is a radians number, so it can't, like it doesn't matter what the units are, but regardless, what happens is that you just and do you remember how earlier I said that, like, I divided all of these by, say, square root of 2 here? That's what's going on here. You're just going to divide all of these by the r. So the sine of theta is actually the r. Sorry, I said divide by r, and so I should have put it y over r, and then cosine of theta will be x over r. Tangent of theta is actually just going to be the y over x. Then cosecant of theta is r over y. And then secant of theta is r over x. And cotangent of theta is going to be x over y. So again, these are really, right, the same formulas as over here. So if I went and I actually put an r here and an r there and an r there, but r was equal to 1, then I have the same formulas. So that's why I think that this thing right here is confusing to people because if R is equal to 1, then you have some special formulas and you don't really need to like memorize them as being special. You just need to substitute 1 when you see that the radius is 1. And if it's not 1, then you know, you have some number other than 1. But that means if you label these like the X is 8, the Y is 3, and the R is square root of 73. So the first one is going to be Y over R. So 3 over the square root of 73. Or, and remember, it says you do not need to simplify these if you don't want to, but you could, but it would be 3 square root of 73 over 73. So again, it doesn't matter. Either is okay, but don't give a decimal. And then cosine of theta is X over R. So 8 over square root of 73. And then tangent of theta, Y over X. So 3 over 8. Then cotangent of theta, X over Y. So 8 over 3. Secant theta, R over X. So square root of 73 over 8. And then cosecant theta, R over Y. So square root of 73 over 3. So do you have any questions about that one? Because again, these formulas just are here, but they really are just the same formulas like over and over and over again, but then they say them in a different way, and that just is what really, like I said, what I think gets to people. So I don't want you to like see them as being different, but I'm looking for like where I put, I don't know what actually where this page goes now. Oh well. I'll probably like look at this later on and think that this is bizarre that oh, you know what, I found it. Yeah. It was back here where these were the formulas. Yeah, it was like right here, I think. All right, so then I think that was all of the types of problems for 7.4, but oh no, I don't think, maybe they're not, no, because there's 7.4 is actually these last 3 also. So I'll go over these 3 and then we'll save the graphing for Thursday, because the graphing actually I think is something where it can be difficult or it can be relatively reasonable depending on what you know what you want to do with it, but this is it. So these are all trigonometric identities, and I promise that this is not like the only like section where this happens. So I don't think it's a bad thing to like practice them early. So if you actually like look in the lecture notes, there's a couple of examples of using trigonometric identities that are like on the notes already worked out, but I would say that the more of them you look at, the easier it will get. Like some people are very good at them. Some people like, you know, even though it gets easier, it's still, it can be difficult. So the issue then, if you want this written as a single trigonometric function, then it says simplify the following expression, write it as a single trigonometric function of t, for example, sine of t. So you don't necessarily need to make it into sine of t, but right now, though, all of these are different. One is cosecant, one is sine, one is cotangent. So that's the point, is that they're all different. So I would again like make a list of basic identities, but one of them is the reciprocal identity. So I know this is difficult, but the cosecant of t is equal to 1 over the sine of t, and then cotangent of t is equal to cosine of t over the sine of t. So that's one of these to remember. So then if I look at this one right here, then I can rewrite it as 1 over sine of t minus sine of t over cosine of t over sine of t. And then what I would do from here is try to, because it's a double fraction now, or yeah, a complex rational expression, try to find a common denominator, or you could just clear the fraction. It doesn't really matter. But if you do that, then you could multiply every term, but this really does mean like every term by sine of t. So multiply every term by sine of t. So why would I do that? Well, these divide out, so I'm left with a, you know what, I'll do the other ones on a separate sheet of paper, but it's 1 minus sine of t times sine of t. And this notation might take a little bit of getting used to, so I'll just write it like this for now, and then over cosine of t. But that's 1 minus sine squared t over cosine of t. So that's better, because you don't have 3 different functions in there now, right? You only have sine and cosine. So if you are like thinking like, yeah, am I done or not? No, you're not done, because you want to still get this to a single identity. Now, here is where I think people get tricked. All right, so what is with the Pythagorean identities? So there are a few of them. So this is where I think that these are ones I would actually take note of. Like those ones are actually not too bad, but these are the ones where I feel like people like mix them up. So sine squared t plus cosine squared t is 1. And then that also means though that sine squared t is 1 minus cosine squared t, and that cosine squared t is equal to 1 minus sine squared t. So those are the sorry, I'm looking up the other ones I wanted to tell you, and I don't, like, it's not that, they're not, I just don't want, you know what? I probably should have just like. Yeah, actually, you know what? I never saw this website before. Now that I see it, I feel like. Yeah, I've never seen this website before. Like I literally have, apparently there's a website called trigidentities.info, and they have all of those three that I just said across the top. And there's like, the other ones I was going to write down were those, but I I've never actually, believe it or not, like I never actually I've never seen this website before. So this is actually very, I don't actually know like what else like there is on here, but it basic trig identities. Huh. Well, anyway, like this could be helpful, but the ones that I really would say to know would be the ones where I just said them right there. Oh, and then this was the, I think the other one was this one. This was the picture with the,
Oh my.
yeah, the picture of the, I don't, okay, I can't figure out why this is doing this, but this is a picture with the hand that I was going to show you. So I don't know why, like this is, I'm just gonna print it out now before my computer like goes crazy on me. Like I feel like it will at some point. So anyway, that's what my comment is that there's other like forms of these identities that I would at least like try to um remember are out there. So then this one then would be, see, 1 minus sine squared t is cosine squared t. So this is cosine squared t over cosine of t. And then one of these divides out, so it's cosine of t. So this whole thing is cosine of t. So do you have questions about that one? Because it is a lot of algebra and a lot of like going back and forth with these. But I feel like, again, it's just a bit of like practice, and like once you uh, know what's going on, it will be easier. So I can like, this one is actually easier than the last, like the last one that we just did. Number 6, number 7 is easier actually. So actually this one is 8 is a little bit easier depending on what you think about it, but number, okay, so 7 is sine of t plus cotangent of t times cosine of t equals something in terms of, right, one function. So right now you have 1 and then 2 and then 3 different functions here. But if you remember the last problem, I said that the cotangent of t was cosine of t over sine of t. So I'm going to use that one again. So cotangent of t is cosine of t over sine of t. So then this will end up being sine of t plus cosine of t over sine of t times cosine of t. And that might not actually look like it is helpful, but if I have sine of t and then this is actually cosine squared t over sine of t, then it is helpful because now I'm just down to, right, sine of t's and cosine of t's. So as long as I have like fewer overall number of different functions in the problem, I've made progress. But then if you look at this, I'm going to use that identity again. So it will be sine squared, 1 minus sine squared t. So use cosine squared t is 1 minus sine squared of t. And so from here, oh my, sorry, from here, then let's see, we have sine of t plus 1 minus sine squared of t over sine of t. But this is good, but there, it's not a single trig function yet. So it's like you have to simplify it a little bit more. So I'll like split up the fraction, and they call this the, oh, somebody is here. They call this the termwise addition. So termwise addition. So this will end up being, it is a sine of t plus the 1 over sine of t minus the sine squared t over sine of t. So just like split up that fraction right there, but that makes it a little bit easier because then one of the, right, one of the signs of t's can divide out. So divide out sine of t. So we're left with sine of t plus 1 over sine of t minus the sine of t. And then this minus this is 0. So then you have 1 over sine of t. And then that is actually, if you remember, that was cosecant of t. So this whole thing ends up being cosecant of t. So that's what the result would be, as the final like result is a single trigonometric function. So do you have any questions about that one? Because like I said, this one, it takes maybe a little bit of like getting used to, but I feel like it's not the worst. But if there's any like specific like steps or identities you wanted to see, just let me know. Okay, so again, just work on them and make a listing of them as you go. And I feel like it won't be like too bad. But let's see, where is number 8? And then number 8 will be our last one today. And then on Thursday, we can go over the graphing and anything like that. So, or any questions about 7.4 or whatever is the most helpful. So 8 is 1 plus secant of t over 1 minus cosine of t. So this is, again, like there's two different trig functions here, a secant and a cosine. So I would recommend that you, now this is in the lecture notes, but I'll say a little bit differently here, maybe. Excuse me. So if you see now, by the way, there's definitely like there's there's definitely more than one way to do this one. So it doesn't really matter, but I would say that if you see a like if you have a rational expression, so a rational expression. So if you have something like this where it is of these forms, it just keep this in mind. So if you have, say, 1 plus or minus some trig function, and it doesn't matter which one it is, in the in the numerator or denominator, then you might want to try multiplying by the conjugate. So what I mean by the conjugate is that if you like if you've forgotten what that means, it means that, in other words, in other words, 1 plus the trig function and 1 minus the trig function are conjugates. So that is the now, by the way, this is actually not technically right, but it's the way that's said in the lecture notes, because you have to remember that this is, if you want to be technical, it's a factor of 1 involving the conjugate. So I mean, like, it's in this case, right? Your choices are, in this case, your choices are going to be 1 plus secant of t over 1 minus cosine of t. So the conjugate of the 1 minus cosine of t is 1 plus cosine of t. So you could do that one. Or because they both have a 1 in them, see what I mean? They both have a 1, that you could actually try to use the conjugate of the 1 plus secant of t and do 1 minus secant of t. So the only thing that you need to really, again, keep in mind is that when you do the conjugate, these are going to be opposite signs, and these here are opposite signs. So I really feel like that is like part of the thing about conjugates, is if that's the tip you are given, then you just have to like pick one of them and then go with it. But this is not necessarily, like I said, like an easy one. Now, again, that might not even be the way that you decide that you want to do this, because I realized that, now that I think about it, that that might not necessarily be the easiest or the quickest way, but in terms of like making sure that you know that strategy, I wanted to point that out. So if you wanted to say like change to sines and cosines, you could, All right, so I just want you to be aware that this existed, but yeah, you could change the sines and cosines first, but I feel like if you do that, I can write that. I'll just write that in the yeah. Hold on. Yeah, I'll just put that version in the notes that I scan and put online because I feel like that is what I was saying earlier. Like sometimes, like just having a different method can help you like see something that you didn't see before. So I would just pick one of these. So if I go with, say, this one right here, then in the numerator, so 1 times 1 is 1, then 1 times cosine of t is cosine of t, then secant of t times 1 is secant of t, and then secant of t times cosine of t, then over 1 times 1, then 1 times cosine of t, and then negative cosine of t times 1, and then cosine of t times negative cosine of t, so minus cosine squared t. And then I will zero those out right here. So I'm left with 1 plus cosine of t plus secant of t plus secant of t cosine of t all over 1 minus cosine squared t. But that actually, if you look back, was 1 minus cosine squared t was sine squared t. So that right here, it equals sine squared t. So then this is 1 plus cosine of t plus secant of t plus secant of t, then cosine of t. And then what happens next? Well, that's all over sine squared t. So then what I honestly would do is this. I would say, well, all right, then that is 1 over sine squared t plus, now break all the fractions apart. So cosine of t over sine squared t plus secant of t over sine squared t plus secant of t cosine of t. And then this is, well, over sine squared t. This actually, now that I think about it, this actually might not, this might make it worse. Oh my. Yeah, this is what I thought of to do first, and then I think that it might take a lot longer than I thought. So this might not be the best way, which I mean, there's not really like an issue with that, but it just that I don't, now that I think about it, this might not be the best, like the quickest way, because you have like yeah, I don't want to like make this worse than it is. So this is what, if I think about how to make that quicker before Thursday, I'll tell you. But this is what I really would do, like to make this quicker, which is why, like I said, like if you try to go down some wrong end and it doesn't work out the way that you think it should, then it's okay. It just might take longer. I did realize that. But if you change the secant of t to 1 over cosine of t, and then you really like you can see what happened here. They wrote that as 1/1, then found a common denominator and then added that straight across and then multiplied by the reciprocal. So that was that reciprocal right there. And so then those divide it out and you get 1/cosine of t, which is secant of t. So that was probably the quicker way, but not that this was wrong. It just, I think it was going to take a lot longer than I thought in my mind that it would. So I don't want to like make things worse. Like I do want you to see that there's more than one way, but and that sometimes like you have to like find out for yourself which way is going to be easier for you. But other than that, no. So do you have any other questions or anything you want to see? Because like I said, like this next quiz isn't due for a while. So like just if you want to start working on the practice quiz now, that's probably good. And then we did like 1 through like 7. We'll go over 8 again on Thursday, do some of the graphing and then go from there. But anything else you want to ask or want me to go back to? No. Yeah,
I
go
just
ahead.
had a sorry, I just had a quick question about like getting like a retake on the previous
Oh
quiz.
yeah.
So we just need to email you like showing that we got 100 on the
Yeah, just well,
practice.
yeah, like I can go and like I'll go and like I can see that you got 100. So just once you email me that you've got 100, I'll reset it for you.
Okay. And is there like a like like we should take like about a week, right? Like
I mean, like
to
I would say maybe a week just so that you like don't uh like get behind on this next chapter, you know.
yeah. Okay,
Yeah.
that was my only question.
All right. Yeah. So just like I said, like just take your time, but don't take too long. All right, then that is it. So like I said, I'll see you on Thursday, but email me if you need anything before